Hello, my name is Larry Flint. I teach physics at Williamsport Area High School, and I developed a method to measure Brewster's Law with polarization with a piece of lab equipment that I designed and built myself at very low cost. And this is an instructional video as to how to build that same kind of piece of equipment that does a pretty good job of measuring angles very precisely and holds polarizers in place. You'll just need to make a trip to Lowe's to gather the materials. So the one thing you'll need is one of these angle finders. These angle finders are available at Lowe's in different kind of colors. They're interesting in that they have a weight to always keep the needle pointed up, and it tells you an angle of an object relative to level with the Earth's surface. You also need some PVC pipe. There's different types of PVC fittings. This is a PVC fitting that's a 3/4 inch to 2 inch adapter, and you'll need some 3/4 inch pipe. The pipe's very inexpensive and you don't need very much of it, so if you buy one 5-foot piece it'll be plenty for your whole lab. I built 12 of these setups. They come in about $5 a piece, and you end up with a piece of equipment that's very similar to equipment that Pasco or Vernier sells for a much higher price. So what you got to do is get some 3/4 inch PVC pipe. It really doesn't matter what color it is. Usually it just comes as white, but CPVC will work okay, or you can get the gray colored pipe, especially from the electrical department. And I cut it into pieces about 4 or 5 inches long, and the 3/4 inch PVC just slots into the 3/4 inch by 2 inch PVC adapter, just like this. You just slide it right in. And then I had some split loom. This is used to bundle cables, and they sell this at both Lowe's and at Radio Shack. And the idea is that this comes in long lengths, and you can use it to wrap cables. But I use it inside this 3/4 inch PVC tube to act as an extra barrier for light, to reduce the amount of light spillage that comes into the apparatus. So it just pushes in real nice, just like that. And then you'll need a 2 inch to 2 inch coupler, and luckily at the time Lowe's sold black ABS pipe and fittings. They no longer do, so white will work, or whenever you're finished with all this and you have them built, you can spray paint them black. The black helps absorb extraneous light, but I don't think it really makes a whole lot of difference what color it is. Well, anyway, you got your 3/4 inch to 2 inch PVC fitting. That slides into the 2 inch coupling, and the coupling doesn't have to be a pressure coupling. It can be the regular 2 inch drain waste vent coupling. And then you also need a 2 inch female adapter with a street fitting. The street fitting is a fitting that fits inside the coupler. And you can put these together in a little bit different ways, but this just turned out to work out just right for me. The most important part of the apparatus is actually a 2 inch PVC cap. And the 2 inch PVC or CPVC caps are used to cap off plugs, usually used for drain waste vent applications. And what it comes with is just a cap, and the cap has a square nut on top that's used with a wrench. So you tighten the fitting down with a pipe wrench or a similar wrench to get the thing tight. This is the piece that you have to modify. So all I did was just took a hacksaw and I sawed down flush with the top of the cap all the way down to the far side like this, and then cut again in this direction straight down. So what you end up with is a hole that's shaped like a square inside the cap. You've got to leave this one part on because this is used as a reference for finding the angle. What this apparatus does is it takes two polarizers, which whenever they're lined up allow no light to travel through and allow light to be blocked dramatically. Let me demonstrate. You take a piece of paper like this and hold one polarizer up to the paper. Light is transmitted from one polarizer to the other, and depending upon the angle of the second polarizer, you can either make the light be completely blocked or allow for up to 50% transmittance according to Brewster's Law. These are Kodak brand or Polaroid brand Polaroids. They don't have to be Polaroid brand, and they don't even have to be in these round plastic fittings. But what was remarkable about this project when I started in on it is I found that the caps for the 2 inch CPVC are exactly the same size to allow these polarizers to slide in. They slide in snug, they fit nice, you couldn't have asked for a better fit. If I would have designed it myself, it would have been exactly like this. This sits in just like this, and you're allowed to turn one of them. The second one fits down inside the apparatus, and I usually hold it into place with just a piece of cellophane tape. So the concept here is that you have one polarizer that's fixed in position inside this tube, and the second polarizer is in this cap which screws onto the end. And you only have to screw it in just a few turns until it's in there relatively snugly. And what's great about this apparatus is that you can mount the apparatus on a stand, like so. Turn it this way, so that the majority of the apparatus is fixed in position and it's nice and level, while the cap is allowed to turn freely. And so imagine way down in here there's one polarizer that's always at one orientation, and the orientation doesn't necessarily have to be vertical or horizontal with the table surface, but the second polarizer is able to move. What we use the 3/4 inch PVC pipe for is we have these light sensors provided or available through Vernier. They're also available through Pasco that have a small photosensor in the end. And inserting this photosensor into the 3/4 inch PVC pipe, and the photosensor will also fit into a 1/2 inch PVC pipe, so long as you don't use the plastic stuff, the plastic split loom. That the light sensor is up against one end of the polarizer, and the other polarizer is on this end. And Vernier has a nice pre-made experiment to measure Brewster's angle, or the confirmed Brewster's Law according to the principle behind how polarizers work. And what the program asks you to do is input an angle relative to one polarizer relative to another polarizer, and then the sensor measures the intensity of light. So what the angle finder is used for is like this. You start out with a polarizer at some position, and you can call this angle like a reference angle of 0, and then if you want to increment by 5 degrees, you can just turn the cap until the angle finder reads whatever angle you're looking for by 5 degree or 10 degree increments, and you just continue to turn the cap, each time removing the angle finder until you get the angle you're looking for. What I have students do is I have them set it up so that the polarizers initially allow for maximum transmittance at an angle of 0 that's level with the table, and then go by 5 degree increments all the way around until they reach 90 degrees, at which point the transmittance should be at the minimum. So a few other things about this apparatus, some benefits that it has over the commercially available ones. The commercially available ones are expensive, and if you need to buy a lab set of like 12 of them, it can really dig into your budget. This you can build on your own. The commercially available ones have a big problem with light spillage, because usually all it does is takes two polarizers, puts them some distance relative to each other, you shine a light in, and but light can spill out into other places in the lab. This helps contain the amount of light. The light that you bring into this apparatus is usually from a DC power supply, supplied light. There's a problem with using AC power supplied light in that there's a variance in the power with the AC current. So you can either use a flashlight, and what I discovered is you can just buy cheap LED flashlights from Lowe's, set the flashlight up at that end, shine the light in through the polarizer, and as long as you have some kind of shield back here, you can have multiple people working at multiple lab stations at the same time. The only downside to it, it doesn't look perfect, but kids get a better handle as to how the whole thing goes together and fits, and we get very good data. The experimental results are wonderful. So if you're in the business of teaching physics and something about Brewster's Law and polarization, if you don't have a way to do it in the laboratory, I highly recommend this. The other thing is, rather than using the polarizers that are fitted to those plastic, the cheapest way to get polarizers these days is if you go to a 3D movie, they give you polarized glasses. One of the lenses is polarized vertical, one of them is polarized horizontal. Just pop those lenses out, and you can affix those to the inside of the cap and the inside of the other end. And it doesn't even matter left or right or their initial orientation, because as you rotate the polarizer through 90 degrees, you'll discover that the amount of light transmittance varies from about 50% of the max to 100% of the max. The other thing you can use this apparatus for is if you unscrew the cap and you remove the polarizer from, I went the wrong way, and you remove the polarizer from the inside, you can also use this apparatus to measure polarization by reflection. So you pull the first polarizer out, and now you're left with just one polarizer. And mounted on this stand, you can use the lab table as a surface that is similar to like a road surface, where the sun is reflecting off the road and there's glare from the road into the driver's eyes. Wearing polarized sunglasses dramatically reduces glare. In that case, to run the experiment, all you do is you set up with a single polarizer in the rotating cap, you adjust the apparatus down at some angle, and you take the flashlight and shine the flashlight in so that it strikes the surface of the road, which we use the black lab table surface to simulate. So the light comes in, strikes the road surface, and bounces up into the polarizing apparatus. And what your student should find is that when this is oriented in one direction, it allows for maximum light transmission, nearly 100% of the reflected light, and at 90 degrees it should block the light almost entirely. And that experiment also works well. Students can also see that phenomena occur just by peering down through the open tube, with the light sensor removed. If you peer down through the open tube and turn the cap, you can see a change in the intensity of light. So holding two polarizers relative to each other allows you to see changes in intensity. This just allows you to quantify it and put it together at a very low cost. So that's it. If you have other questions or want to get in contact with me, my website address is mrflint.com. That's just mrflint.com. And my email address is available on the website. Thanks a lot.